In this video, we are going to learn discount rate, discounting factor, and we'll also look at the relationship between discounting factor and accumulation factor. Now, before we proceed on, let's recall what we learned in the last video. So, in the last video, we saw that when present value is multiplied by the accumulation factor, it gives accumulated value. And this accumulation factor is time bounded, meaning that if present value is at 0 and accumulated value is at n, then accumulation factor should be from 0 to n. Or if present value is at t1 multiplied by the accumulation factor, if accumulated value is at t2, then accumulation factor should be from t1 to t2. And then we saw that the accumulation factor in case of simple interest is 1 plus ni, okay, and accumulation factor in case of compound interest is 1 plus I to the power n. And then we saw the principle of consistency. Principle of consistency. For example, suppose this is the number line 0, 3, 7. So from principle of consistency, I can write the accumulation factor from 0 to 7 as accumulation factor from 0 to 3 times accumulation factor 3 to 7. Or I can break this any number of times. For example, I can say accumulation factor from 0 to 2 times accumulation factor 2 to 4 times accumulation factor 4 to 7. But this should be consistent, right? Now let's look at the discount rate. Let's understand this from one example. Suppose you have $100 in your bank account and your bank gives you 10% interest rate per annum on $100. So at the end you'll have $110. So this is your accumulated value and this is your present value. Now this some percentage on the present value is nothing but the interest rate, right? Now what if I ask you what percentage should be charged on the accumulated value? So this is same. What percentage should be charged on accumulated value to get the present value back? So this is the question. Now suppose you charge X percentage on accumulated value. So this X percentage is nothing but the discount rate. Okay. Now you can say that the interest rate is linearly charged on the present value and discount rate is linearly charged on the accumulated value. Okay. Now similar to interest rate, we have two types of discount rate, that is simple discount and compound discount. Okay. Simple discount is also called commercial discount. Commercial discount. And compound discount is also called effective rate of discount. Rate of discount. And I think in previous video I forgot to mention the synonyms for compound interest, that is effective rate of interest, effective rate of interest, and this is also called risk discount rate. Discount rate. So these are few terminologies that are often used for compound interest and compound discount, simple discount. Okay. Now let's look at the discounting factor for simple discount and compound discount. And let's compare with the accumulation factor of simple interest and compound interest. So in simple interest, when present value is multiplied by 1 plus ni, you get accumulated value at t equals to n, right? So in simple discount, so this is the accumulation factor. Now in simple discount, when accumulated value is multiplied by 1 minus nd, you will get present value at t equals to 0. So this is the discounting factor. Okay, it was accumulation factor, this is discounting factor. Now in compound interest, when present value is multiplied by 1 plus I to the power n, this gives accumulated value at t equals to n. And when in compound discount, when accumulated value is multiplied by 1 minus d to the power n, it gives present value at t equals to 0. So this is the accumulation factor and this is the discounting factor for compound discount. All right. Now let's see how we can establish the relationship between accumulation factor and discount factor. So here one thing you notice that when present value is multiplied by the accumulation factor, it gives accumulated value, and when accumulated value is multiplied by the discounting factor, it gives present value, right? So from these two relation, I can see that the accumulation factor is the reciprocal of discounting factor, or discounting factor is the reciprocal of accumulation factor, right? I can say this, right? So this is the relation between accumulation factor and discounting factor. Now let's look at the notation for discounting factor. In accumulation factor, we have the notation an. This also means accumulation factor from 0 to n, and if there are two different times, then we write accumulation factor from t1 to t2. Okay. Similarly, in discount, we have vn for discounting factor, and this is the reciprocal of an, or I can say a0 to n. And also discounting factor follows the principle of consistency. So if discounting factor is from 2 to 7, then I can write this as a2 to 7, or I can break this as a, let's say 2 to 3 times a3 to 5 times a5 to 7. Okay, and then this is nothing but v23 times v35 times v57, right? So principle of consistency can be applied in discounting factor as well. All right, so this is all about the discount rate and discounting factor. Now before we end this video, let's make a chart that will be very useful for you while solving the questions. It will contain all the discounting factor and the accumulation factor. So let's make a chart. So I'm going to draw 3 columns. So in terms of simple interest, accumulation factor for n years, and discounting factor for n years. So in terms of simple interest, the accumulation factor for n years is 1 plus ni, and then discounting factor would be the reciprocal of this, so 1 plus ni to the power minus 1. And then compound interest, accumulation factor is 1 plus I to the power n, then discounting factor would be reciprocal of this, which is 1 plus I to the power minus n. And then for simple discount, the accumulation factor, or let's say discounting factor first, that is 1 minus nd, and the reciprocal of this is the accumulation factor. Similarly, for compound discount, the discounting factor is 1 minus d to the power n, and then accumulation factor would be the reciprocal, that is 1 minus d to the power minus n. Okay, so this is a small chart that can be very useful for you while solving the questions. Okay, so now let's stop here and I'll see you in the next video. Thank you so much for watching this video.